Match problem 6 is another problem that will start off following the same pattern as all of our substitution problems, but is going to require a little bit of extra innovation on our part to get this problem completely rewritten to the point where we can evaluate it. So we'll start off with the straightforward part. Our interior function here is x plus 1. X plus 1. If we take the derivative of both sides, the derivative of x is 1, derivative of 1 is 0. So we just get du equals dx, or du equals 1 times dx, if we wanted to include that in there. This means that we can rewrite our problem as the integral of x, because we didn't swap out that x with anything, times the square root of u du. So x plus 1 was replaced with u, and dx was replaced with du. But our problem now is that we still have this x, which was our original variable. In order to integrate, we have to replace all of the x variables with something in terms of u. So what we'll look at doing is actually another substitution. We're actually going to start with the very same substitution we started with, but we're just going to make use of it in a different way. So we started off with the substitution u equals x plus 1. So we're going to start off with that same expression, but now what we need to do is rewrite this so that we can swap out x. In this case, if we subtract 1 from both sides, we'll get x equals u minus 1, which means now we can rewrite this problem and replace x with that expression u minus 1. So now our integral becomes the integral of u minus 1 times, and actually instead of the square root of u, let's rewrite that as u to the 1/2, since that fits our integral and derivative properties a little better. U to the 1/2 du. So now we have all of the x variables removed, dx is removed from our problem. We're ready to go ahead and integrate, but first we'll distribute u to the 1/2 through this expression. Giving us the integral of u to the 1/2 times u will be u to the 3/2 minus u to the 1/2 times 1 will be minus u to the 1/2 du. So since these are two terms being added or subtracted from each other, we can just integrate term by term, which means this will be u to the 3/2. Sorry, we're adding one, so u to the 5/2 divided by 5/2 minus u to the 3/2 divided by 3/2 plus some constant c. Or we can rewrite this as 2u to the 5/2 over 5 minus 2u to the 3/2 over 3 plus some constant c. And now in our last step, we want to replace u with x plus 1, that original substitution. So this will be 2/5 times x plus 1 to the 5/2 plus or minus 2/3 x plus 1 to the 3/2 plus some constant c. So again, from the very beginning, we started off with our regular substitution procedure, but that substitution didn't get rid of all of our x variables, so we go back to that original substitution, solve it for x, so that wherever we have x, we can rewrite x as some new expression in terms of u.